Hi everyone. Today we're going to be doing the debugging in GitHub code along. This is not helpful for a specific project. This is helpful for all your projects because debugging is one of the most valuable skills that you're going to learn in this course. It can save you loads and loads of time, especially as these projects get harder. Uh, these involve skills such as navigating the IntelliJ debugger, but also just reading error messages, understanding error messages, different types of errors, and general good practices when debugging. Unfortunately, we aren't going to do the GitHub part of the code along. It does require a partner. If you attended the code along live, you got to see myself create a contrived merge conflict and resolve it. But a lot of it is similar to what we did in lab and just watching a TA navigate what happened in lab. So you can always review the lab handout. And Google is an amazing resource for GitHub. Honestly, that's where I learned all my GitHub merge conflict solutions. But yeah, on to the debugging part. So to start, we're just going to give the program a run. And how this is going to work is we're going to go through just a bunch of bugs that are present in this program. And when we first run it, we can see we get this message in the terminal. Java semicolon expected. And what does this mean? This one might hopefully be a little self-explanatory. Java's saying that we're missing a semicolon. But I want to highlight a couple things. First of all, what type of error is this? This is a compile time error. A compile time error basically means that Java can't even compile our code. What is compiling? Compilation is the process of turning Java code that we write into zeros and ones that the computer can understand. And here Java is saying that something's a little broken with your Java code. And we can see that if we start looking around, it might be really hard to find where this semicolon is. But we can use the terminal, specifically this blue link is really helpful because it takes us right to where we want to go. But if you didn't have the blue link, you can also use this information. 13 is the line number in this class, constants.java, which we can see it was 13. And 47 is kind of the character indent, but really the line number is going to be the most helpful, 13. So this should hopefully fix our compile time error so that our code can now compile. Let's give it a try. So it did fix our error, but we have a new one. And again, this is a compile time error, but it's a different one. This time, Java, or more accurately, the process of turning Java into uh, bits, zeros and ones for the computer, um, the compiler could not understand this symbol. And it's saying the symbol is an ellipse. So again, it took us right to the part of our code, but we could click on the blue link and get exactly where, right, line 13 character indent 17 of the alien class. And we see it's this dot face is equal to ellipse. And some of you might be screaming already what the error is. But again, I want to highlight that this cannot find symbol means that Java doesn't understand what ellipse is. Is ellipse a method? Is it? And you might realize again that what we need is the new keyword. We're trying to instantiate a new ellipse, but we forgot new. So again, another compile time error, and it's important to understand that this is compile time because we don't see our program running, right? Java can't understand what we want our program to do. And let's give it a try. So again, we fixed our error, but we now have a different error. And now again, we can click and it takes us exactly to where we want to go. And it's another cannot find symbol error, but this time it's a little bit different, right? We are not missing a new. What exactly is the problem here? And again, Java is telling us that it doesn't understand what get root is. So here we have our pane organizer, and we're trying to call the get root method, which we'll have in all of our projects. And so maybe it's a good idea to see what's going on in pane organizer if we have a get root method, because we are trying to call organizer.getRoot. And you can see it all looks pretty standard, but at the bottom here we have get roots. And again, just a simple little error, and it seems contrived, but at the end of the day, these are small errors that are really easy to mistake, misspelling a method title, or a method name, sorry. And here we can fix this, but it's important to understand that cannot find symbol doesn't just mean one thing, like we're missing the new keyword or right? These different errors that Java can throw at us and the descriptions the terminal has can mean a lot of different things. But in general, Java cannot find symbol has the same overlapping reason for appearing, and that's Java doesn't understand one of our commands or a part of a certain line or a method call. And let's see what happens now. So finally, we get our program. And immediately we get an error. Let's see. Array out of bounds. So here we jump to this section of the code, which is array examples. And what we want to do is we want to figure out what happened to create this array out of bounds. And the most important part that I want to highlight is that there's a lot of red. And this can be super intimidating because a lot of times you'll have errors that will create tons and tons of red in the terminal. But ultimately, we need to understand what is happening down here to better understand our errors. So to start, this is the stack trace. What the stack trace is it's the sequence of calls that our program made while it was executing that led to this error. And it works in reverse. So this was kind of the first call, and then it goes all the way back up, or sorry, the reverse. This was the final call. And it goes all the way back up to what the first call that was made that ultimately created the issue. And if we click on the purple link, right, these are all blue links. That's kind of the stack trace, the flow of control of our program. So, right, we make a new pane organizer. We have this setup buttons method, the button pane. We have a new array example. And then in the new array example, we have this dot populate array. What is this dot populate array? And now we have this issue. And if we take a further look at our array example code, um, we can see that we have an array of size 10. And we want to populate this array by saying for every number from 0 to 10, set that index equal to that number. And some of you might already be screaming what the problem is, but something really important to remember is that although our array has size 10, it starts at index 0. So we have index 0, 1, 2, 3, 4, and we have 10 indices, so 0 through 9. And if we try and access outside the scope of these indices, right, if we try and access -1 or 10 or 500, we're going to get an array out of bounds exception. So if we hand simulate what's going on in populate array, we can see that we're going to start at 0. We're going to say this dot number 0 is 0. And then we're going to increment. And then we're going to say this dot number 1 is 1. And we're going to go and go and go. And then when I is equal to 9, this dot number 9 is going to be 9. And then for 10, we're going to run again and say this dot number 10 equals 10. But again, although we have 10 slots, we're only indexing up until 9. So what we really want to do is stop at 9. And this is a really common issue, but one way to do this is to say less than 10. You could also do less than or equal to 9. But it's normally pretty standard that we keep a less than and we do the full size of the array. And again, it's important to see the stack trace, right? The order of calls that was made. So we can trace back exactly where the start of this, the source of this error was, and then also to see that Java is telling us it is an array out of bounds exception. So we don't need to go hunting for what type of error it is. We're being told that we're accessing a part of an array that doesn't exist. And again, up here, another important thing, Java will tell us it's a runtime exception. This is different than a compiler time error because Java actually compiled our code and began running it. Just upon running it, it ran into this issue, which is that it tried to populate this array, and unfortunately, we accessed a part of the array that didn't exist. So let's again go back and try running it. All right, and we're finally seeing our alien, or at least part of our alien. We'll maybe look into that in a sec. But we have, oh, okay. So let's see what happened here, right? We try and move, but we're not really getting much luck. So again, we have this stack trace, and it's really important. A lot of this is Java FX, right? This is deep buried in Java, but if we scroll up through our stack trace, we can see eventually, we actually get to the pane organizer, right? And the pane organizer is a class we wrote. And now we can see two things. We can see the pane organizer with the line, right? By clicking on this link, we got told which line the error is happening on. And we also got told what type of error it is. It's a null pointer exception. And null pointers are extremely common. What it means is that we are trying to call a method or do something with an instance of a class that we think exists but is really null. So here we're doing two things, right? We're setting on action this button B2. We're telling it something. We're saying set on action, alien move right. But we're also potentially doing something with the alien, right? We're saying when this button's clicked, hey, alien, move right. So which of these could be null? Well, I see B2 here, and I see B2 exists. So that already kind of tells me I should have a good hunch of what's null. But I also want to show how we might use the debugger here, because in bigger programs, it might be a little confusing what instance could be null. So if we put a breakpoint and we go back to app and we debug. Oops. Let's see, it might register the wrong breakpoint. Nope. So it came here. And already we can see, if we go here, we see B1 is an instance of a button, move left, B2, but up. And again, we could see this dot alien is null. So we're saying, hey button, to us at least, it looks like we're saying, hey button, when you get pressed, move the alien to the right. But to Java, this dot alien is nothing. And almost always what this means is that we declared but forgot to initialize our instance variable. So if we go up top, we can see we have an instance variable alien, which again, Java is telling us is null. And we should be initializing this instance variable. But you may remember the syntax for initializing an instance variable. Currently, we're initializing a local variable, and we really want this dot. And again, we could have scrolled through the code for a little while, tried to figure something out, and maybe we've said, aha, that's our issue. But using the debugger is a really powerful tool because if you get used to it, it can save you a lot of time just putting a breakpoint and seeing what information you get from the debugger. We also talked about in lab how to step over, step into, and do all those similar things. So it's good to review that. And also in the more complicated projects, it's going to be really helpful to know how to use the debugger when there's more code, more going on. Terminate. And now hopefully we've fixed our null pointer. Ta-da. So we do have some more issues that we need to address. First of all, let's see what's going on with our alien, right? And unfortunately, we don't really have eyes or a face. So let's see what's going on. And to talk about different types of errors, right? We talked about compile time errors and we're finished with those, right? We solved all our compile time errors. And then we had a couple of runtime errors, right? A null pointer exception and the array index out of bounds exception are runtime because what happened was Java went to run our program and it tried to execute some certain command and it failed, right? Whether it was indexing the array or it was trying to move the alien. Now what we have is a logical error, right? Java is running our program fine. We're not getting errors in the terminal, but we're missing, right, this left eye and right eye. So it's just a logical error on our part that we failed to do. So let's see what's going on here. And logical errors in some ways can be the most difficult because it's not really helpful as much to use the debugger. It can be, right? If you want to know what certain values are at certain times, that can definitely be a logical component. So if you're updating the state of your program and you want to know and you want to keep stepping over and seeing logically how things update, that's definitely a good case. But in this case, it's a little bit less helpful to use the debugger, in my opinion, um, just because we just need to figure out where the eyes are. And looking through our code, we could see that this left and right eye, the center of the X is unfortunately at 0. And let's see if that's our problem, right? So we can see if we have a constant. And we have all these constants that aren't being used. So we can also figure out what the problem is there. Oh, I actually think that's just my IntelliJ, right? They're being used here. But we could also see that maybe that wouldn't be the problem. Another problem I'm noticing is that, right, we're never actually adding it to the root. And that's a really big problem because remember in Java, now that we're doing stuff with JavaFX, we always have to add things graphically and logically. So we're logically creating our left and right eye, but they're never actually getting added to our root pane. So let's see if that changes anything. Find symbol. Whoops. I messed something up. So L, yeah, that's my issue. Whoops. There we go. And now we have another issue, right? The issues just keep coming. But to put a pin in that, I guess it may be helpful to use the debugger at times for logical errors, and it's always a tool you should have in your toolkit, right? The debugger. But sometimes it might just be helpful with the logical errors to just kind of look back through the parts of your code where you're dealing with certain things, right? I went to the part of my code where I'm dealing with setting up all that logic and just evaluated what was happening, what was going on. At first, I thought it was a problem with this center X because the 0 looked a little funky. But then I realized that, nope, actually, we're just never graphically adding it. Something that's really important to keep track of. Always logical and graphical. Um, and we could see maybe the reason that it doesn't matter that it's 0 here is because we have set X location and we have start. So we're actually just starting. We're initially initializing the variables to 0, but then we're just setting them down here. So a good skill to always look back through your code and figure out what's going on. But again, another logical error, right? We have move right and we're going left, and we have move left and we're going right. So a good thing to do is to go back into our move right and move left methods and see what's happening. And it looks pretty standard, right? Pretty solid. We're setting the X to where we currently are, plus some offset. And we're also printing out our constant, which is distance, and we see that it's negative. And that should immediately tell you that we're taking where our center is, and hopefully it's not reverse on the zoom screen, but we're taking our center and we're subtracting when we want to go right. And that's just a classic logical error, a negative sign off by. So what we can do is change the value of distance x. And this should hopefully solve our problem. Another logical error. Always be careful with these small logical errors. Negative signs in your move methods, great. And we're all better. Another thing, if we click this, right, this is calling our array example method where we initialize all the numbers. But the final thing, I'm not realizing, hopefully you guys can see the execution, but if not, you can always be running it on your own. If we click the bottom right button all the way that says array dot dot dot, we can make the window bigger too. Array lists, we get this error. And this is the last thing I want to talk about today. Again, if we scroll through the stack trace, we can see this is a runtime error because it's throwing all this red. And when we eventually get up to what's happening, we can see a pane organizer. We press the button. So it's showing us you press the button and we called a.changeArrayList. And what is that doing? This is, if you look a little bit more through the code, you'll see that we've set up a list And we want to iterate through the list using a for each loop. And we want to print out the word. And if the word is Andy, we want to remove it from our list. And what ends up happening? We can see that when we run it, we print Andy, and then we get concurrent modification exception. And hopefully this is familiar from lecture, but the general idea of concurrent modification is that when we use a for each loop over a list, we can never modify the contents of the list. And we see that in this case, we're using a for each loop, and when the word is Andy, we remove the word. So we are modifying the contents of the array. And this is really important because the for each loop is really handy and great to use when you just want all the elements of a list. But if you need to modify the contents, you cannot use the for each loop because you will get this concurrent modification exception. Luckily for us, there's a way around it. So let's comment out this loop for now. And we can equivalently use a for loop and get every element of the array. So let's set up a for loop. Int I equals 0. I is less than, and let's wait for a second on that. Sorry. Right, so we're going to iterate over our list. And what should go here, right? What do we want to iterate until? I should keep going until I is at the very end of our list. And we could say this dot cool words, and for array lists, right? Cool words is an array list. We have this dot size operator. And just like before when I said it was standard to have this less than the size of the array, it kind of comes from this fact that we can always use the dot size, and we don't actually need to have the size of our array list handy right there with us. We can just call this and always say less than, and we know the indices are going to work out. Because if we have an array list of size 23 at one point, dot size is 23, I less than 23 goes until 22. So we're always accessing inbounds elements. And we can say that the word is going to be the ith index of our list, right? Again, so we're taking values of I up until the size, and then we're accessing that element. And now we want to print out the word, same as always. And are we done? So let's hand simulate for 1 sec. We know the first word is going to be Andy. And we know the second word is Django, and the third word is code along. So let's hand simulate. When I is 0, we're going to get the 0th element, Andy. If the word equals Andy, which it does, we're going to remove it. Okay, great. So Andy's taken out of the list, and we know array lists automatically resize. So now Django shifts up to index 0, and code along shifts up to index 1. And now we increment I, right? Because we did this, we removed the word, and we increment I one more. So now I is 1. This dot cool words dot get I, get the first index, is now code along. Because remember, Django shifted up to index 0 and code along shifted up to 1. So we see that we wanted to loop over every element in our array list, but we actually missed an element, Django. So what can be done to fix this? Well, when we remove an element, we need to actually check the same value of I again, because our array shifted everything over. So if the word equals Andy, and we remove that word, we should decrement I. And now what happens is when I is 0, we remove Andy, and we decrement I. So I is now -1. And the array list will auto shuffle again, right? So Django 0, cool words, code along is 1. And then we increment I, right? Because we go through another iteration loop. And now I is 0 instead of 1. And we check Django as we want to. This is a longer explanation, and hopefully you can hand simulate and maybe see why, hand simulate on your own and resize the array and see why we really need to decrement I in this case. But ultimately it solves our array index out of bounds because we're not using a for each loop anymore. We're using a for loop. And let's see what happens. This is very important for doodle jump because you're going to want to use an array list and you're going to want to modify the array list. And it's going to be tempting to use a for each loop, but you're going to have to use a for loop because if you want to modify the array list, right, and we see we get all the elements. But that's all we have for the debugging lab. And the highlights of this really were the different types of errors, logical, runtime, compile time, how to use the debugger, right? Setting up a breakpoint, debugging null pointers, and generally there's so much to do with the debugger and getting practice with it right now when the programs are simpler compared to the final project and stuff will be really helpful. So when you feel comfortable when we get to the biggest projects in the course. And finally, we talked about some important array, right? We talked about this first example where we had our size was, or our index counter was off by 1. But we also had this really important concurrent modification example that will come up again. So thank you so much for joining me, and I hope you got something valuable out of this. And as always, debugging hours is a really helpful tool where TAs can explain their thought process of how to debug, and hopefully you got some of my thought process of while I was going through these bugs.